Hey guys, this is the problem we are going to discuss today, but the code force is unavailable for now. So I'll copy paste the link in the description of this video. So as always, we are going to explain the example first. So the problem will give us a tree, and the first number is the number of nodes in the tree. And the second line will give us the colors of those nodes. So for example, the first node has color 2, which is the blue color here, right? And the second node don't have any color, so it's 0. The third node doesn't have any color, so it's 0. The third, uh, the fourth node is color 1, which is red, and the fifth is blue, right? And then the following lines describe the edges. So the first edge connects these two nodes. Second edge connects these two nodes. So all in all, this describes this tree here. So what we are going to do is to find out the good edges in the tree. So what is a good edge? What is bad edge? So the good edge is that this one is a good edge because on each side of this edge, it has at most one color, right? For example, uh, we take this edge as an example. This part only has color blue, so that's okay. And this part only has red, so it's also okay. So that is one good edge. Let's take a look at other edges. So for example, this one, for this edge, this side has one color, good. But for this side, it has two colors, so this edge is bad. So we need to find how many edges are good edge. So for this example, there is only one, which is this edge. So how do we solve this problem? So first, I'm going to make this graph more like a tree. Um, actually, so I cannot rotate this graph. So uh, let's just think about it. So let's say this guy here is the root, right? And this guy is its child, and these three guys are this guy's children. All right. So this is a tree, right? Um, and we can start from this node, and we do a deep first search. So we search all its children, right? And in the end, when we reach a leaf node, that is the node that doesn't have any children. So this node, we have two counters. One counter is count the number of red colors on this node and its subtree, right? So this node is the leaf node. It doesn't have a subtree, so the counter of red node is 1, right? And the counter of blue node is 0. And for this guy here, also the counter of red node is 0. Obviously, it's this subtree doesn't have any red node. And the counter of blue node is 1 because this guy is blue, right? And for this guy, uh, the red node is 0, and the blue node also 0, right? Uh, Actually, it's 0. So for this node itself doesn't have a color, but the subtree of this node has a lot of color, right? So we can add them up so that the counter of a red node of this tree is 1, and the blue node of this subtree is also 1. And we trace back for this node itself is blue, so we can add its subtree together, and we can know that the red node is 1. The blue node is 1 plus 1 equals to 2, right? So why do we need the counters for each subtree? So we can do this. So we can deep first search again, and when we already know root the root tree here has a total number of red nodes and blue nodes, right? And when we doing deep first search, and when we on this edge, we can know the counters of its subnode, of its subtree here, right? This is a counter of this subtree. And then that means we know the counter of this side. So we can easily determine if there are 2 colors on this side of this edge, right? We just check if both of the numbers are bigger than 0, right? And how about on this side? So on this side, we can easily just decrease these numbers from the total number, right? That is the counter of this side. And if in this case, let's calculate it. So in this case, the total of red number is 1. And there is one red node on this side. So there are 0 red number on this side. And there are uh, one blue node on this side, and there are 2 nodes in total. So on this side, there is 2 minus 1 equals 1 blue node. So we can check it. So on this side, it only has one number bigger than 0, which means that it only has one color. And on this side, it has 2 colors. So we can know that this is a bad edge because it has one side that has 2 colors, right? That is how we decide is the edge is a good edge or not. So let's take another example, this edge. So for this edge, its subtree's counter is here, and the total counter is still here. So on this side, it only has one number bigger than 0. So it has only one color on this side. And for this side, we do the calculation. We use this number minus this number equals to 0, which means on this side, there are only one color, right? There are 0 red color nodes. And for the blue color, there is 2 minus 0, which is 2. So we can know that on this side, there are 2 blue nodes and 0 red nodes. So we can know there is only one color on this side as well. So that this edge is a good edge, right? So we solve the problem. So let's take a look at the program. So we have a small function here, which determines if both, if one of the, let me see, if no, if not both of the numbers are positive, then we return one, right? That's a little function we are going to use in the program. And for the main function, first we are going to read how many nodes, and reading the colors, and reading the edges. And we are going to count all of those subtrees. So here is where we count the subtrees node colors. So first, we are going to increase the counter by one. Depends on the color of the current node. And then we are going to travel his children. And basically, we are doing deep first search and traverse all of those children, right? And for each child, we are going to add the child's counter into the main node's counter, right? Thus, we are going to have the all of the subtrees counters. And then we are going to calculate the final answer just by using the little function we described before. And this is the part where we decide if a edge is a good edge or not. If it is a good edge, we're going to increase the final answer by 1. And in the end, we're going to output the answer. So we can, because we can easily calculate the total number of blue nodes and red nodes, so that actually we can get this done in just one deep first search, all right? I'll left it to you to make that happen. So thank you for watching. See you.